So, good morning to you all from my side. My colleague, which was announced in the prospect, called Mike Wonneberger, was not able. He's very sad, but he couldn't make it today. So I'm his replacement. I hope I'm gonna make it, as well as he would like it. So first of all, I want to show you the problem that underlies our business case. The second point, I want to show you why Invent is part of the team and how we're gonna participate in solving this problem. Then I'm going to show you what kind of solution we persecuted, and subsequently we come back to money, because money is all we want to make, money is we live by. And I want to close up with a small dedication on how iForum has helped us to persecute these goals. Let me show this business case. First of all, I want to mention we have a discrete business case, but underlying is furthermore the idea to develop methodologies to deal with, in our case, the problem of vibration. It was vibration, positioning, and what was the last one? Oscar? I don't know. Can't remember. Okay, so, pardon? Deformation, yes, please. Thank you very much. So we deal with vibrations, and this business case here shows an impeller. Impeller is part of a turbo machinery or turbocharger, and it rotates very rapidly. So we have high rotation and we want to have little mass. So how are we going to achieve this? We're going to have thin walls, and if you think of these thin walls, this impeller is milled in one piece. And the thinner the walls, the more complicated it is to mill. Because the thin walls start to vibrate. So we're going to deal with vibration. If you have a stick in your hand and you try to chop it and the stick vibrates, you can imagine how difficult it is to have good quality and fast machining times. So our problem is that we get chatter marks on these blades, which diminish the quality of our product, or we have to reduce the feed, the machining feed. So at the end we have loss of loss of time and the loss of quality, or in the worst case both. So what was the idea? The idea was to improve the machining by improving the fixture. What we need is an intelligent fixture who can counteract these vibrations. So what do we need for this? First of all, we have this business case here provided by an end user using this technology of milling and manufacturing these impellers. Secondly, Invent, here down below, this is us, provides the sensors to measure those vibrations. CTEC, up above here, provides an actuator which acts against those vibrations. And the University of Magdeburg, which is also in Germany, and provides a system technology to process the incoming sensor signals and to process the signals for the actuation to actively damp the vibrations. And the University of Dortmund supported this by developing simulation of tooling, which helped to predict the desired effects. So the solution for our vibration problem is, as I said, the intelligent fixture. And how are we going to achieve this? We have a clamping plate, which is shown here. Or this is, I think this is close to the final result. This is here just a prototype. And this damping plate is, clamping plate is integrated between the workpiece and the fixture and helps to assess the vibration. And I'm going to show you the solution from the view of Invent, because to show the aspects from all other involved companies would be far too large, and we have to focus on, or I will focus on our part. I haven't forgotten anything. So to assess these vibrations of our workpiece, we have to have a complex sensor system, and that is where Invent comes in. So what is our expertise? If you look at our website, we are rather a composite technology specialist. But if you have a look at this thing here, this is a piezo patch if you think it, plainly, it's also some kind of composite because you have ceramics in the middle and you bake it with protection foils, and then you can bend it. So we already have this. This is a piezo sensor, a piezo patch, converts strain to voltage. So in either way. What we already do is we customize this in any direction. And what we also already did is to integrate those piezo patches in structures. And what we get is intelligent structures. And then the question is, where can you use intelligent structures? And now comes our problem. We need intelligent fixtures, we have intelligent structures, so there is invent. What was our approach? Our approach was to start from the series product we already have and to enhance it. What kind of enhancement do we need? We need a very complex sensor system. That was our new technology. And in addition to that, we have to make it very durable because it acts in a rough industrial environment with milling, chipping, cooling, lubricants, and has to be durable. And starting from this, we developed the clamping plate, and this is our new product we can use. Just check the time. On the right side here, you see further prototype, which was also tested because it's manufactured with 3D printing. It's made from metal. The final product is made of C4P. Okay, so this looks quite simple, or you could say, well, sort of that. But you can be sure that to derive at these simple forms, we had a lot of prototypes and we developed different kinds of sensor systems and cabling to be able to achieve the targeted goal. Okay, as I said, let's come back to money. What comes out for Invent? Invent has developed a new product. This is very direct. But as I said, underlying is the idea to develop methodologies for acting for vibration or damping for vibration with intelligent structures. And for us, the cooperation with the machining industry opened up a new market for us. So, and there were already collaborations following this where machining or measuring industry said, we need actively damped structures or we need intelligent structures. Can you help us? There are already subsequent projects following this. And at the end of the day, we want to be in 5 or 4 years to make our turnaround in 2020 with piezo sensors and customized piezo sensors and intelligent structures with about 5%. And this leads to, this needs to be done by employees, so we suspect to employ further employees, right, up to 2 or 3 employees who cover this demand. The improvement for Giggle is also, at the end. They have a damped fixture. They can increase their quality. They can increase their feed time. And thus, differentiate themselves from the market. And they can increase their portfolio and also think of their new standing, where can we apply this technology as well for damped structures, for fast manufacturing or for fast measuring. Also, you can imagine if you measure very rapidly with a machine, you need active damping at the end of each positioning. How helped for I4MS for us? So I4MS helped us to set up this project, especially if you think of SMEs who depend on innovation but do not have dedicated R&D facilities in their companies. So I4MS enabled us to have those cross value chains and come together with integrators from the universities and to meet, for us as technology providers, for us to meet the end users proposing the problem. And last but not least, it helped us very effectively with the dissemination. Otherwise, I wouldn't have so many interesting people listen to me now. Because the best idea is nothing worse if nobody's interested, if nobody knows it. So this is why I'm here, and I thank you all for listening, and this was my presentation.